Since Charles Darwin introduced his theory of evolution more than a century ago, evolution has become the concept that unifies all the biological sciences. Fossils clearly show that organisms have changed or evolved through time, and the course of evolutionary history becomes better defined as new fossils are continually discovered. A familiar example of the evidence of evolution is the unusually complete fossil record of horses, which extends back more than 50 million years to the earliest recognizable member of the horse family, Hyracotherium. This tiny ancestor of the horse, sometimes called Eohippus, meaning dawn horse, roamed the warm subtropical forests of the Eocene epoch, feeding on the soft, leafy vegetation. A close look at the teeth of Hyracotherium reveals a simple pattern of bumps and ridges on their chewing surfaces. The premolars were smaller and more slender than the molars and contributed little to the grinding of food. Then, about 40 million years ago, the climate became cooler and drier, favoring the spread of grasslands and the reduction of forest habitat. To exploit the more abundant grasses, horses needed more durable teeth because grass leaves contain grains of abrasive silica. The premolars gradually became larger and more complex until they resembled the molars, and the molars and premolars together developed an increasingly complex pattern of bumps and ridges. With Merychippus, which lived about 15 million years ago, a second major advance began in the adaptation of teeth for grazing or eating grass. A bone-like substance called cementum formed around the crowns of the developing teeth, filling the depressions around the bumps and ridges. The teeth could thus become very tall and yet remain strong. The higher the crowns of its teeth, the longer a horse could eat abrasive grasses before its teeth wore down to the roots. The teeth of later horses, such as Pliohippus and Equis, became progressively higher crowned and extended far into the sockets in the skull and jaw, from which they slowly emerged as they wore down. The proportions and shape of the skull changed dramatically to accommodate these tall teeth. A grid of the same points on each of the skulls reveals the change in position of the eye socket from above the teeth in Hyracotherium to behind the teeth in Equis. Horses adapted in many other ways to changes in their environment. Hyracotherium had flexible four-toed feet suited for the moist forest floor. As forests gave way to grasslands, the feet of later horses adapted for running on harder ground. The middle toe of each foot, which bears most of the weight, increased in size while the side toes decreased. In living horses, the side toes are completely lost, and the foot bones that bore them are reduced to slender remnants on either side of the foot. Elongation of the foot bones produced a longer stride. This, combined with physiological changes, gave horses the speed and endurance for fleeing predators in a habitat where hiding was no longer possible. The changes seen in horses from Hyracotherium to Equis are dramatic evidence of evolution, the process that enables all living creatures to adapt to changing environments.